Alright, so today's quiz of the day is an example problem where we have a mass that's hanging from the ceiling and it's attached by two strings. And so there's a knot right in the middle here, and that knot allows us to actually make kind of an assumption. We'll show you what that is right now. So if I'm to draw this, again, we have that string, we have that other string with the knot, the string hanging down, with our mass hanging on top of it. Well, we can conceptualize this by actually taking the mass and pretending these two strings are attached to the mass, because really there's no difference. So when I draw the force diagram of this object, what I would actually do is I would start out by drawing the mass, and again we know we were given a couple things. We were given the two strings and the angles that they're at, plus the force of gravity acting on it. Now this is somewhere where people make mistakes. They see this 100 Newton force down below. We know that's the force of gravity, okay? But people make the mistake of seeing this and automatically multiply it by 9.8 because they're like, yeah, take times 9.8, that's the weight. Remember, the force of gravity is equal to mass times gravity. Well, we're given this 100 Newton force, okay? We don't have the mass, and we do have gravity. So be careful here. That 100 newtons is, that 100 newtons is the force of gravity. Okay? Now, the other two forces we have a force of tension that's working up and to the right at a 45-degree angle here. Okay? So we'll draw it like such. That's Ft. We'll call that Ft1. Okay? And if it makes a 45-degree angle here, it also makes a 45-degree angle there. So again, it's up to you to take and look at this whichever way you want, okay? And then we have another force of tension that's acting to the left, okay? They tell us it's at 90 degrees. It's 90 degrees with the wall. So we know this is directly to the left. We'll call this Ft2, and we know that that is acting exactly perpendicular to the force of gravity, okay? Now, we also should know that anytime we have a force at an angle, that means that we can break this force up into y and x components. And so this is going to require some trigonometry for us to do. Okay, so we'll call this Ft1x because that's the force of tension 1, and that's the x direction. And we'll call this one Ft1y because that's the force of tension in the y direction. And so I don't have any other numbers other than this, but I have one more thing that I can work off of. If you guys remember, we know that this object should be at rest, which means the sum of all of the forces will be 0. They'll all add up or they'll all cancel out. Now, a lot of kids don't use this notation, so instead I like to talk about the forces up being equal to the forces down, and the forces left will be equal to the forces right. And so if we look at this, if I break this down into x and y components, we can pretend as though it's not there. And then it becomes real simple to see my force of gravity and my force of tension 1 are exactly equal and opposite because this is up and this is down. Those are the only up and down forces, which means they have to be equal. Okay? Likewise, because of that, my left forces will equal my right. So my Ft2 will equal my Ft1 in the x direction. So I know that this should be equal to that. Okay? Now as it turns out, because this is a 45-degree triangle, my Ft1y and my Ft1x will be equal as well. So I can do a lot of this work without any math. Let me show you. If f of g is 100, that also means that this Ft1y is 100 newtons. Okay? Being that this is a 45-degree triangle, I don't even have to do math to know that this and this are the same thing. So this is also going to be 100 newtons. And then the last thing that I know, because of this being 100 newtons, that also means my Ft2 is going to be 100 newtons. Okay? And so finally then, we would need to solve for our hypotenuse. And so there are a couple ways you could do it. You could use SOHCAHTOA, or you could use a squared plus b squared to get c squared. I'm going to do that. So a squared plus b squared to get my hypotenuse c squared. So this is 100 squared plus 100 squared is equal to c squared. And so doing the math real quick, we get 20,000 is equal to c squared. And so if I want c, I'm going to take the square root of both sides. And I get a c of 141.42. So that means then, this FT1, which was my c, is 141.42 newtons. And so that's an example of how to do a force diagram, quantitative force diagram, of an object hanging from the ceiling like this one.